Hello and welcome everyone back to Space Simulation Toolkit, where last time we looked at some of the crazy things we can do with planets, but I've been playing around on my own and things have only gotten more crazy. Guys, the amount of things you can do with this game is literally insane should your computer be able to handle it. So let's go ahead and build a planet. Got a bit of stone here. I learned recently that you can shift scroll to change the size of your brush. Pretty useful. Let's go ahead and put some dirt on top of this planet. We put a little gravity thing. Oh, I made a mistake. I made a terrible mistake. I did that in the wrong order. It's fine. This is just gonna floop. Oh, okay. I mean, it's cracked it a tiny bit, but that may actually create some interesting effects in the future, so that's fine. So the thing about Space Simulation Toolkit is that there's just so much you can do. It is literally insane. You can simulate some crazy stuff. So let's go ahead and drag a sun here into the center. So the sun is going to heat up the center of this planet and kind of act like a core. Technically, yeah, it's supposed to be used as like a star, but why do that when we can use it in ways it was never originally intended? Well, maybe it was intended. If you want to ask the guy who made this game what was intended, you can go over to Valor.gg because he joined! He joined! The guy who made this game joined Valor. He's talking to people about the game. You can even suggest features to him there, and he will listen to you. Well, he might not add them if they're dumb ideas, but you guys are all intelligent. You're my subscribers, right? You're subscribed? If not, you should subscribe. All right, so let's go ahead and get this sun and turn up the amount of energy that it's emitting. I'm just going to turn that up to, what, 12? So you saw the title of the video and you saw that it had plate tectonics and you went, how does that work? And the crazy thing is because of this guy made this simulation so accurate with particles that there's a bunch of emergent possibilities which I don't think were originally intended, but just because it's how physics work, it works. And it's awesome. So what we're gonna do is we're just going to pump up the heat here. And then you're going to see what I mean when I say plate tectonics, because we're gonna get some really, really awesome shifting crusts on this planet. Here we go. Here we go. Just gotta get that heat a little bit higher. Let's just boom. Up, up, up. All right, so now we have a very nice molten core. And what's happening is as the molten core melts the internals of this planet, it's actually going to do some interesting things. The first thing is that the liquid is a little bit less condensed than solid, so it's going to expand and push a little bit and cause a little bit of stress. There's already cracks all throughout this planet, so we don't have to worry about that. But we can do some really cool things. Like, for example, I can inject water into this. So watch this. If I get water and I'm going to turn off the change material so that it just adds new material, if I inject some water into here, you know what happens when water touches heat, right? It's going to turn into steam and actually expand. And we want that, because it's going to increase the pressure in the core. There's a few different ways to increase pressure. You can just pump in more and more and more of a material by turning down the C distance, which is the distance away it can draw from. But I like using steam because steam is fun. It's also a great game store. So let's go ahead and get that steam in there. And now there's a bunch of water surrounding this core, and it's getting really hot. It's becoming steam. It's expanding outwards, and it's starting to go through the cracks. Because the simulation is so awesome, it's actually going to force the water through the cracks as the amount increases. So let's go ahead and turn on the C distance on this so that I can pack more than one atom in a space, and that's going to cause it to do this, which is I'm forcing more water into the core than can technically fit, which is creating pressure. We're fitting more atoms into this space than are supposed to. So what they're going to do is they're going to want to escape. And not just that, but they're being heated up. So between those two things, between the heat and the expansion due to me just shoving more water into the same amount of space, we're getting just this intense amount of pressure in the core of this planet. And I'm going to abuse this. I'm going to add more and more. And now we've got kind of a mantle forming, as you can see. Now you may be wondering why I'm not using lava. I found that using lava, the balance between it actually forming stone and heating it is kind of challenging. It's a lot easier to do with just superheated water. But for the purposes of this video, we're gonna pretend that this superheated water is basically lava. And now we can see the pressure is starting to force along these fault lines, which were formed when we built the planet. Actually, remember how it cracked? Well, those cracks are now being found. Look at this. Look as the water is trying to find a way to escape all this pressure. It's actually forcing this crack open. And in real life, the Earth actually does have these spots where over time have shifted and created basically cracks, which have formed the plates and the plate tectonics that we have now. It's leftover remnants from when the planet was forming and the big things that happened during its development. But look at this! This crack is slowly being widened as the pressure continues forcing through. And any second now, it's going to get to the surface. Of course, we can speed up the process as well, but because the heat is only increasing, look at the flow as well. We've got this really neat flow going on here as the heat causes this convection to go around in circles. Oh man, it just looks so cool. Does this not look absolutely awesome? Like, you can simulate this on your computer right now if you get this game, Space Simulation Toolkit. I'm basically a salesman at this point. All right, so over here, we just have a ton of pressure, which is actually breaking some of the stone up into sand. Like, it's intense. And right here, we can see it's just about to get out. Oh, it's gonna happen. It's splitting. It's splitting. It's splitting. It's hitting the dirt now. It's hitting the dirt. Dirt is not as strong as stone, but look, it's shifting the plates. It's shifting the entire surface of the planet. Like, is that not absolutely insane? And look, more and more and more pressure is starting to build up. It's starting to push through the dirt. There's so much, this huge piece of stone here is being moved. This is gonna form like a mountain. It's gonna push him. Oh, look at all that. Whoa! Oh my God. Look at all of it. Look at all of it go! Oh, that is so awesome. That is so cool. It is so cool. Like, I cannot even tell you how awesome that is. And all of it's becoming ice and falling back down, making the planet even larger. Guys, was that not super satisfying to watch? That's gotta be like the top 3 most satisfying things that ever happened on this channel. We literally just watched the core of a planet erupt out, and I didn't have to do anything. I personally didn't do that. I just put some pressure in the center, and it found the most optimal route to crack out and explode outwards. All right. And so, if you have a torus or a donut like this, the outer edges are actually going to be able to hold themselves a little bit, right? Because there's still some structure here. It's pushing on itself, so it really doesn't want to fall inwards. But we're going to increase the amount of gravity so that it does want to fall inwards. This is going to be cool. Watch this. All right, so I'm gonna grab this gravity node here, and I'm gonna go ahead and I'm gonna turn the multiplier up. And you're gonna notice that as I turn the multiplier up, it's gonna start pulling pieces that are loose off of the planet and melting them. Yep, we're getting a lot of stuff falling out of here because this is just ice. And then over here, we've got this crazy amount of cracks that are starting to fall in. But you're really gonna see any second now. Let's double this again. Double the gravitational force. Now we are, did I do, no, that's correct. Now we are really seeing a lot of stuff fall in. Look, big chunks of the stone are starting to fall in. This is all about to collapse inwards. And what's going to happen as this stone falls in, it's gonna start using these cracks and they're gonna start sliding, and we're gonna see continents and oceans form as this slides. This is already closed up here. The crack is closed because it's falling inwards. All of this, I could speed it up a little bit, but I think it's a little bit more satisfying if we're just patient and watch this take place. The planet is literally crushing, and oh, there we go, there's a big piece just fell in. And now the tectonic plates are actually going to start sliding. Now we're getting some convection here. It's this plate is coming in and going under, this plate here is going up above. And as you can see, this is breaking and it's forming. A hill here is actually getting pushed out by the force. And look over here, these two plates are coming in this way, and it's actually pushing this out and forming a hill. All right, I'm gonna deal with my dog really quickly so that we don't have to listen to her barking the whole time. So give me one moment. All right, so things have moved. Things have moved. So look, this plate here has formed and it's slipped up, creating a mountain here. Over here, we have not as much, but look, there's two plates here that are colliding and they're moving and it's actually pulling inwards. Look at that. And then over here, look at that. That's a massive, massive plate that's going under the other plate. So this is super close to, in real life, how this works, with the tectonic plates either slipping under each other, colliding and moving up to form mountains, colliding and then bending down, going back into the earth, melting. It's not a perfect representation, but like, it's so good. Like, look at that. Look at that fault line. Like, it's slowly slipping under, and this plate is going over, and it's just a beautiful simulation. It's so good, and we can increase the power further. Let's double the force of the core again, which is going to create even more pressure, which is going to cause, look at this mountain that's forming as these two plates collide and push upwards. This is literally insane. Literally insane. I'm sorry. This has got to be one of the most insane things that I've ever laid my hands on. Look at it go, and it's forming these cave systems as well, these massive caves under the earth. We've got these mountain ranges that are just forming. It's so good. Now, I may have overpowered it. I think that it's going to begin melting everything, and I think the entire planet is probably going to die. But it's worth it to get this sort of content. You know, whoever lives on this planet definitely understands that the content must be made. It just must. Oh, look at that. 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 That plate's actually about to go vertical? Yo! Geologists on this planet would have a really fun time trying to figure out how all of these formations formed. All right, and let's go ahead and have a little bit of fun and add a little bit of complexity. We're gonna turn down the gravity now, which is gonna cause all of this material in the center. There's actually too much. The only reason it was able to pack so tight was because of all that gravity. So now we have just a ton of pressure in the center. Does that sound familiar? Does that sound a little familiar, having a ton of pressure in the center? It should sound familiar, because I believe we're actually going to get some magma going out. Oh, it's actually, no, because it's less tightly packed. It's actually cooling down a little bit and it's forming stone again. That was unexpected, but I understand why it's happening. But there is still a lot of pressure. There is still a lot of pressure. This is why I didn't use lava, because the lava has a tendency to become stone again. But there is still a lot of pressure, and I think that we're actually going to see some material come through here, through this crack. Maybe? Possibly? I don't know, there's a lot of pressure going on over here as well. There's a lot going on. All right, let's go ahead and stuff some water into it and see what happens. It's probably gonna form an ocean on one of the fault lines. All right, there we go. That was a huge injection of water, probably way too much. It's actually causing the core to go kind of wacky because of the amount of pressure I just injected. Whoop, whoop. Oh, it's finding its way. It's finding its way. Is it? I thought it was. I thought it was, maybe not. Oh, geez, the core is really starting to expand again now. It's like, it's slightly balanced. Maybe not. All right, let's inject a tiny bit more. All the pressure. Oh! Whoa! It just pushed that entire glacier out. Oh, and we're actually getting lava. We're actually getting lava coming out. Not just water. That pressure was so much, and now it's forming new stone too. Look at that. Wow. All right, that was insane. That was pretty crazy. That was pretty crazy, my guys. All right, so finally, let's do one last thing in this video. I'm going to build a meteor. I'm gonna build a meteor to crash into this. So I'm gonna build a giant piece of metal way out here. Oh wait, I need to turn, whoops. I need to turn the C distance back to 1 so I can build properly. I still don't know how to type directly into this. The developer said you can, but when I click, it doesn't give me the ability to, it just either doubles it or halves it. So maybe I'm just dumb. I am probably just dumb. Here we go. This is good enough. All right, that was stone, but I guess that's fine too. Now we're going to heat this up. We're gonna heat up this bit of stone ridiculously. Boom. Super heated meteor incoming. 3, 2, 1. Oh! Do you see the amount of damage that did? Whew! And now the heat from that is actually transferring to the planet, and it's going to be a bad time for anyone living on it. Actually, so much heat has been added that the core is having an easier time melting the center of the planet. And I think the entire thing's about to melt. Oh, maybe not. Maybe not. Maybe it's balanced. Yeah, I think it actually survived. Crazy. This planet's been through a lot. So let's go ahead and pop it like a balloon. That's the only way to give it. It's really a reward being popped like a balloon, if you think about it. Insane amount of pressure. Go. Ooh. Oh. Oh, it's been vaporized. It has been completely vaporized. There is nothing left of it. I put so many particles in one space that the friction caused it to just immediately just melt. Oh wow! Look at the size. I mean, the material is falling back down. Can you even comprehend how many particles this is simulating right now? Like the amount of math happening in my computer? Absolutely ludicrous. A lot of this is actually the gravity is causing it to be pulled back in. And we can speed up that process as well by doing the old gravity increasing multiplier trick, which I will do. Oh, it just caused it to collapse into itself and create shock waves. Whoops! Hate it when that happens. I wanted the opposite to happen. I wanted it to go, things to go in, not to go out. Oh well. Is it done bouncing now? No. The answer is no. The answer is we have just vaporized this, and this is all that's left of the planet. Well, thank you all for watching. Leave a like if you enjoyed, and subscribe if you want to see more. Also, remember, Valor.gg. The guy who made the game is there right now. Bye.